Hello everyone. I'm going to talk today about machine learning applied to customer feedback. So I'm André, the big guy in this picture here, if it's not obvious. So my background is computer science and artificial intelligence. So when I finished my degree, I joined KPMG, which I found a bit boring after a while. So I wanted to embrace startups and the big movement here. So I moved to London, where I worked as a software engineer, data scientist, head of data science, and then CTO of Warwick Analytics. So I'd like to understand first a bit about you guys. Developers in here, please raise your arm. Yeah, okay. Data scientists. Okay, good. So nowadays there is a big boom about artificial intelligence, and that is going to save the world. Is easy. Is here. Is just that's it. So the reality is that it's not so easy as that. And what I want to show you guys here is that in Warwick Analytics, what it was since the beginning and how we ended now. So Warwick Analytics, we are a spin-off of Warwick University. Initially, we got the IP from the university, from the mechanical engineering department. It was mainly about root cause analysis. So we started tackling some problems around explanatory analysis on engines of cars, parts of airplanes, pharmaceutical industry, batches, everything that you could apply. You know, you have a startup, you have an IP, you want to explore as much as you can. So, in a startup world, you have a path. That's a really important point. You are here now, but you have a direction, but we don't know where you are going to. So we start approaching root cause analysis in several projects. However, what came towards to us wasn't just root cause analysis, and so we start seeing a lot of opportunities here and there. A lot of them was about classifying warranty claims, understanding and identifying issues in maintenance logs, identifying what are the topics in product reviews, for example. Recently, we tried to classify agent notes from a call center. So lots of different projects, as you can see. However, the big commonality was that all of those data sets, all of those problems were based on text, and we need to classify based on text. So we created a generic use case where we have a customer. That customer provides some customer feedback. That customer feedback can be a product review, can be just a ticket support, for example, on intercom, Zendesk, or even a call to a call center that the agent just wrote down some notes. All of that is customer feedback, voice of customer, you name it. So that the customer provides some customer feedback, somehow ends up in a database. And what the company wants to do is to generate some visualization, some charts. What is happening? How are my customers using my products and experiencing my services? That's what everyone wants to do. And then on top of this, they want to generate actions to improve the business. However, if you have a lot of text, well, you need to extract meaning out of that text. Currently, what is being done out there is you have a lot of people, we call it labelers, that look at the text and just assign labels, tags to it. And of course, if you increase the volume, this is not a scalable problem. People currently, the way that they are tackling this problem is by, well, we get a bigger team, right? And actually, we have some companies that, well, if we have a bigger team, here in the UK is really expensive, so why don't we go and create teams all over the world where labor is cheaper? For us, this is not the way to go, and we believe that an automated approach is the way to go. There are many different ways to do it. A simple way that all us with development background, we are going to think straight away is, well, if I find a keyword like toilets or toilet in a customer feedback, this is going to be about toilets, so I can label with toilets label. However, this is really important that, okay, but what is the performance? Because in machine learning, we have a model, but we need to know how good that model is, how trustable it is, which is performance. So rule-based classification is not a solution. Traditional machine learning classification might be the solution, where you can handle complex signals. So not just it has the word, specific words, but has a context. Have a context or has a combination of words and so on. So to perform this kind of exercise, usually the traditional way is you collect data, you train your models, and you deploy your models, and now you can, so you train data, and now you can predict on the remaining data. The problem is now you have more data coming in, and you predict. More data coming in, you predict. However, the problem here is that you created the models based on the first training set. And you know, yes, for this model, I know what the performance is. But now, the data is going to start changing. The data changes every day. But what if the data changes? Does my model is still applicable? This is a simple exercise that you can understand how the data changes. So there you have the iPhone that was released, and you can see this as a concept of a phone. So before the iPhone, we have phones with antennas, with physical keys. And after the iPhone being released 10 years ago, we have, well, all the keys, apparently they are almost gone. The big screen is the way to go. And if you think now about how the data that was, the customer feedback that was describing a phone before the iPhone was, well, about physical keys, about antennas, and now after the iPhone is cracked screens and so on. So it's totally different. The data changed. So the big problems that we face is the data is going to change. There is no question about that. So when do I need to update my models? And how do we update my models? Because now we collected data, we trained. After that, now I'm running, I'm using my models that were deployed. 5 years later, if I need to update my models, I need to collect new data. So I need to have a project on its own to collect that data, train those models. And at the end is, finally, can I measure performance of those models over time, which is really important. Because if you think of the business that they are going to take decisions that are going to change their business, for sure they want to know that those decisions are based on something that is trustable. Okay, so this is a key point. So based on that, and given all different kind of projects that we faced in the past, we realized that as requirements, well, we need to be able to classify customer feedback based on text. We need to be able to handle non-labeled at all data set or partially labeled, and be able to measure performance over time, update the models over time. And the holy grail that we wanted to achieve was to maximize the performance, the labeling performance, but with the minimum effort of the human being as possible. So we've developed a product that we call Predicx, prediction of customer experience, though that's why the CX there. And the goal was to keep a human being in the loop. This was inspired in active learning, which is a technique from machine learning. And the basic idea is that you have a data set that is not labeled. You request input from a labeler for the true label. So you ask, please label me this data record. The labeler labels that data record, and you start creating a training set. You create a model, you predict, and for the ones that you are not so certain, you ask them, please, can you label those ones? Can you lead by example? Show me examples of what is a registration, or what is I cannot log in, for example. So the main technology that we developed is called optimized learning. As I said, it's inspired in active learning, and the big goals that it tries to achieve is, as I said, maximize the classification performance, minimizing the human input. But there are way more than that. So when you start labeling, imagine that now you have a database of a big supermarket, and you don't know what labels are going to be there unless you start looking at the data. When you start looking at the data, you need to understand the labels, so you need to do class exploration. You need to understand what is there. Once you have the models for that, you need to exploit those models in order to optimize them for the labels that you have. But beyond that, well, now, as I said, we have a human giving me the example. So as human being, everyone can have different opinions. So are the labelers trustable? So that's another problem that we need to sort out. So there are different ways to do it. Maybe consensus is a way. Another problem was, as I said, measure performance over time and keep the models always updated. So this is a scenario of a life cycle of optimized learning, where we started with no labeled at all, and we have a setup period where we have, so this represents over time. You have a constant input of new data. And for the two first time points, the labelers, they need to label, they are labeling 30% of the data set to generate the models. Once the models are set, hands off, now let's just maintain the models. This way, over time, you have a constant labeling from the labelers, just to give examples. And this way you can measure performance, because now, instead of just having in the beginning the training set, now you have examples over time of examples of labels. So this is really important. And so we can retrain the models every time that we have new input. So this is really, really important. And let's imagine that the data now starts changing a lot. So if the data starts changing a lot, you'll know, because you can understand the performance that is dropping, and so you can just simply label more, because that is going to generate a better model. So this is a concrete example where we had a data set, and we sliced that data set into two data sets, one to test, another one, we call it the pool. So that data set was composed in the test by almost 4,000 data records and 143 classes. And the pool was composed by 15,000 data records. So the full sampler that you can see, that is the red line, we just got the whole training, the whole pool, and we trained the model, and we predicted. And what we achieved was that we used the whole 100% of the data set of that pool, and we achieved 82% F-score. F-score is just a way to measure, is an harmonic mean that combines prediction and recall, which is one of the ways to measure performance of a model. So goes between 0 and 1, or 0 and 100%, and the higher the better, basically. So that sets a goal that, well, using the whole data set, we are going to achieve 82%. So now, can we do the same or close, but with less data? That's the goal. So using Predicx, but how this works, is from the pool, we collect a portion of the data set, we train, and we predict against the test. And that way we can, for that training data set, we can know how much is the performance at that point. We increase that training data set again, and we compare it again, the performance with the test. And so on, increase again the training, and test it again, compare it again with the test. So that's the way that we can understand this curve here. So, and this curve, what it means to us is that instead of using 100% of the data set, now we can achieve almost, well, roughly 82% of F-score, so the same with only 15% of the data set, which is massive gain. But what if I don't use Predicx and I just randomly collect one and increase randomly the data set and train and predict? Well, if you do that, and if you don't use the technology that in Predicx that optimized learning that selectively collects the next one that is better to improve the model, we achieve this squiggle line that is not so good as Predicx. That's the big goal here. So at the end, instead of having a huge army of people just labeling, which is a really tedious task, we can have the same scenario, but where we have a person just maintaining the model with Predicx, and that way we can have trustable output and actions that we can rely on. So this is so far, that's a journey that we've done since the beginning in root cause analysis, and now we are in customer feedback, totally different. But if you guys have any data sets that you'd like to explore, given that this is applicable to reviews, customer feedback from, I don't know, trend journeys, so every kind of text we could apply this, feel free to challenge me or grab me after the talk and we can discuss that. Or even if you'd like to use Predicx, just sign up for that online on our website and have a go. That would be great. So if you guys want to contact me, feel free to contact me on this email. And do you guys have any questions?
Just to understand if I understand rightly what you're doing. More or less, your classifier have something like I don't know, and the label say no. In this case, the label should be this one. Is it right, or is something like more complex?
So the idea is that yes, it's just as simple as this is the label that should be assigned to this data record, to this customer review. Yeah.
So have you tried doing this kind of predictions on something that's essentially kind of before it reaches the customer, so on something like Jira tickets or GitHub issues, something that's actually part of a software development lifecycle kind of thing, to see if you can use this kind of algorithm to triage pre-triage issues, because it's labeling, right? So like being able to figure out if this particular problem is in a particular domain, particular part of the system, etc.
Yeah, that's a really interesting one. So actually this week we had just a brainstorm session about collecting logs from our Kibana and try to understand, well, is it applicable? Can we, well, the reality is yes, in principle, yes. Now, do we have a signal there that we can trace and we can identify the labels that we should apply to them? And there's always a context that we need to understand is, are the labels relevant? What kind of labels should I apply to this? Which value can I get out of those labels? Because But in principle, yes, if I could assign labels to those logs and then understand trends on it. For example, imagine that you have an issue on those logs that is, I cannot log in. And now it's quite stable. Suddenly you do a new release, you deploy, and suddenly you have logs, the trend on I cannot log in, just going bananas. Well, I don't know if it's good or bad, that trend, but you guys know what is happening there, so you can have a look. That's a different way that we can use the technology, just even on normal logs, software logs.
Well, if no person is asking, I have a question myself. I generally come from the systems admin background, although I was a developer years ago.
So can
as
you
a C
speak a bit
master
louder?
coder. Can you hear me?
Yeah.
Yes. Now, is it not, you said the F force, that's a fixed F force, a fixed parameter. Now, how do you ingest data? How do you, it's a function basically.
Yeah.
Okay, now how are the variables entered into F force? You didn't explain that a bit more. I want to know more.
So the F score is, so how this works is, in a nutshell, you have the model, you predict. You know already the true labels for the prediction that you are doing, so you can compare if they are correct or incorrect. And for the ones that are correct, you apply functions on top of this set of incorrect versus correct, and you can calculate precision, recall, accuracy, and F score, for example. So it's a function on the output of the model.
Thank you very much.
You're welcome.
Was Karen Peterson.
If I understood it correctly, it sounded like a really important part of the system that you've made is when it sees that the data are changing, which piece of data does it ask you to label to give it the most information gain?
Yes, precisely.
So how does that work? How does it decide?
Well,
Can you not tell me that?
That's part of the IP, right? But in a nutshell, and back to my initial answer, my initial slide. The AI is not here to solve everything, and algorithms are really complex and they need to be looked after and applied correctly. So it depends on the classifier that we are using, the algorithm that we are using. But in a nutshell, how we do it is by having an output of the model saying these are the data records that are more uncertain of my prediction. So if you need to help me, I'm a model, so now I'm a model. And if you can help me on these ones, this is the best. They are the best ones that are going to provide some value to me to improve my model. That's the goal. I think there's a.
As I understood it, the F score, the correct value is done by a human being labeling it.
Yes.
How do other human beings score, obviously, over an F score? So one human being labels it. If you then take another arbitrary human being and ask them to label it, how do they do on the F score? What sort of?
So we never. That's a really good one. So we are not assessing the human being. We are relying on the human being is going to provide the true label, which is a really dangerous assumption. Okay, of course, especially because. Well, people sometimes wake up not so happy, or because many reasons, right? So, in this scenario that I've just showed, you are totally trusting the output of the input of the human being. However, what can be done is that we can see a team of labelers and so we can use techniques like we have a special data set here that we truly is highly curated, and we are going to ask from this data set here that we know the labels, we are going to ask to all of you, some of them here, and actually now we are assessing your performance. Okay, so that's a cheeky way to do it, but we can understand how reliable each labeler is. That's a way, for example.
So what I was interested in is, leaving aside the question of how reliable the person who is the labeler is comparing the computer against the human beings that you might be employing. So the computer's hitting 82%. I was wondering what level of consistency you get from human beings on that. Is the AI as good as, or?
So in that scenario, so in this one here, we are getting, I understand your question. So we had customers that they were achieving 83, 85% accuracy. Now the question is it, even being not so good, just a bit lower, can I use it? Because now the machine does everything automatically, never gets tired, and does that 24/7. So yes, actually, even the situation that we've seen is even being a bit lower is highly useful for our customers.
Yeah, so it's 82 versus 85. I mean, that's a tiny difference.
Yeah. There's one over there.
So you mentioned that you use online learning or active learning.
Yeah.
So how do you control that the balance of the labels, that you don't have one label that is 90% that label, so you get really good accuracy but just predicting one label?
Yeah, so that comes back to the point of class exploration and class exploitation, where we can just explore the classes that we have. So even if you don't have classes, imagine that you don't have labels at all. So at that point, there is nothing that we can improve in the model because there is no model. So in that specific moment, actually, you want to maybe get a lot of random data records just to see what classes I get. And then once you have those data records, those labels, initial labels, now I can start tuning those specific labels. And of course, you can say, well, this label for me is more relevant, so maybe just focus on this label more than the other one. Does it answer?
Yeah, more or less.
Yeah.
One more question?
Yeah, hi. Is there some kind of feedback here where, because it feels like as a customer when I give feedback in English, I like to think that that's going to a human being, and I realize here it isn't. So, yeah.
That's a good
So,
point.
I just wonder whether there's some kind of feedback, so that if I say I was really pissed off about this, that, or the other, whether some kind of feedback comes back saying, we understand that you've complained about the toilets.
Yeah.
Is that correct? And that feels like the customer's the only person who really knows what they meant. So whether there's some kind of feedback loop there that could reinforce your model, and whether you've done anything with that.
Yes. So that's a good point. So the way that the market is going to, we have things like chatbots, and so the human being the one answering to your requests might be just at the end of the days. But I'd say that the most important thing is that if you took a train and the toilet was stinking, the most important thing for you is that next time that you get the train and you wrote the review on the train, the last journey, the next one is going to be clean. That's the most important thing. So if
Yeah, so I'm not talking about the kind of the morality of a human hearing my cries, you know.
Okay.
I'm just wondering whether, for your purposes, whether a feedback loop in terms of I'm pissed off about this, and then just something comes back saying this is how your review or your complaint has been classified, and even just a yes or no, and even if 10% of those customers click yes, that's correct, or no, you've got it wrong.
Yep.
Whether that would enhance your algorithm, I suppose.
Definitely. So as much feedback, as much curated feedback we can have, the better it's going to be. So one thing is actually, if you have a labeler that is a person, the specialist. So we are not talking here a person that maybe just joined the company. If you're talking a really complex scenario, if you're talking about, I don't know, for example, Apple, that the components are really complex and you really need to know the components and why it's breaking. And if you have customer feedback, maybe you need to be a senior engineer to understand that specific feedback and to label with that. So definitely the person here is going to understand, but if you can incorporate that loop, would be even better. Definitely.
Yeah, I was thinking the whole way through about taking the labeler out.
Yeah.
Because the point of giving feedback is making the service better.
Yeah.
So I wonder whether the customer has more.
So actually, for example, so one thing that we could do is once it gets labeled, we send it back, just an email saying.
That's what I'm saying.
Yeah. That's a really good idea.
Use that.
Yeah. Thank you.